So to be successful with vectors, we have to understand a few things. First, we need to understand that when we talk about magnitude, direction, and sense, those three things tell us different things about the vector. So magnitude is really how much force we're putting in there, right? And then we get into just some directions and some sense. Here's what we're really looking at with sense. Think about your XY coordinate plane, right? If we move over to the top right quadrant, X is positive and Y is positive, right? If we move to the bottom right, we know X is still positive, but Y becomes negative. If we move to the bottom left, then we understand that everything is negative, right? X is negative, Y is negative. And then the top left, I think we understand that point, right? So here's the deal. We know that we have 75 pounds right there. So the question then becomes, how much of that is on the Y and how much is on the X? We're pulling in two directions, right? So that's where this SOHCAHTOA stuff comes in now. So we can go ahead and write it out here, right? So we're trying to figure out, let's just go with FAX for now. So again, we can label these, right? We know this is the hypotenuse. This is the opposite. Notice how they've already labeled them right here. And this is A. They give us the angle. So what we've been taught so far, we're going to try to figure out X. So we're going to have to use an adjacent, and we know the hypotenuse. So adjacent and hypotenuse, that means we're going to use cosine. So we know that the cosine of 35 degrees equals, remember it's A, so adjacent, so FAX over hypotenuse, which they give us is 75. So we're trying to get that FAX by itself. We'll take this times 75, and now that's going to cancel, right? And this will go times 75. So if we're trying to figure out FAX, it's going to equal 75 cosine of 35. I'm going to go ahead and put that in the calculator. And when I do, I end up getting about 61.44. Somewhere in there. Okay, so our FAX here is 61.44. Now, in this particular case, I'm going to go ahead and do the FAY as well. Let's go ahead and look here. So let me erase a few things and help it make more sense. So here we go. We are trying to get FAY now. I'm going to say that's opposite, right? So opposite, and I know the hypotenuse, so O and H. So I'm going to say sine this time. So sine of 35 equals opposite, so FAY over hypotenuse, which is 75. Again, it's going to be very similar. It's just a different operation, right? So I'll say times 75, and then again times 75. So 75 sine of 35 is going to give us FAY. So I'll pause here for just a second and put that in my calculator as well. I am going to get 43.02. So in my Y direction, I've got 43 pounds of force, and in my X direction, I've got 61. All right, so here's the other part of it. So what they're showing here is our center. So if we take these red arrows that they've drawn in here, right? First off, which plane are we in, right? Everything's going to be positive, right? Because we're on the x-axis right here. Well, that's in the positive direction. We're also in the y direction. We're also going positive, aren't we? So let's take a look now at what happens when we get something a little more like this, right? So when we get something like this, how do we deal with it? Our x is still positive, isn't it? But our y now has become a negative. It's in that negative plane for y. It's really not that big of a deal. It's going to set up the same way, right? So let's go ahead, and we already know x, right? Because here's our 75 and 35. So we already know x. So let's go back to our previous one here. Our x, we said, is going to be 61.44. X is 61.44. 4. All right, let me go ahead and clean that up a little bit. Instead of FA, this is going to FB. So now we're looking at FBY as well. Now really, we've got the same numbers, don't we? It's going to set up the same way. So here was our previous calculation of FAY right here. And we came out with a 43.02. In this case, we know that that has to be negative, right? Because if we go back here and we look, we know that we're looking at a negative direction there. So really, it's the same number. It's going to be 43.02. However, we're going to have to throw a negative sign in front of it. So when we take a look at another concept, resultant force is essentially, it's the sum of all forces in the y direction and the sum of all forces in the x direction. So let's see here. In our y direction, if we look at our previous, we had a 43.02, and in our second one, we had negative 43.02. So we've got 43.02 and negative 43.02. Well, that's going to equal 0, right? So now let's take a look at our x's. We had, in our first example, we had 61.44, and in our second example, we also had 61.44. So really, these are just going to add together. So really, we have 122.88 pounds going in the x direction, right? So let's go back a little bit and take a look at this. Really, we haven't done anything different than what we've already done. If we take a look at this and we see the setup, right? We look at the SOHCAHTOA. We've still got an angle. We still know opposite. We still know hypotenuse, right? As long as we have two of those variables, we can figure it out. Like, we're always going to know the sine, cosine, or tangent in these particular cases because they give us an angle. And then we're always either going to know opposite, the hypotenuse, or the adjacent. And we can just figure out the rest with algebra.